Okay, now our next topic is nothing but coefficient of coupling between the two circuits. Now between the two circuit meaning is what? Two coils. So let's consider this is one coil and here will be the second coil. Now whenever there is change in magnetic flux in the first coil, then the EMF will get induced in the second coil. Right? So this coefficient of coupling, which is denoted by letter K. This K is nothing but the measure of flux. This K value, coefficient of coupling, gives the measure of flux when flux in the second coil. When that second coil is in contact with the first coil. Contact means in the vicinity of the first coil. So that K will give the measure of phi. Means what? If magnetic flux is maximum, means value of K is maximum. If magnetic flux linked into the second coil is minimum, means K value is minimum. Now here there are two coils, means we can find out the mutual inductance. So if this K value is more, means mutual induction inside the coil will goes on increasing. Means coefficient of coupling and mutual inductance, they are directly proportional to each other. While previous lecture we have seen that whenever there is a change in magnetic flux in the first coil, therefore a flux linkage is in the second coil, which will induce EMF in the second coil due to change in magnetic flux in the first coil, which is directly proportional to M. M is nothing but the coefficient of mutual inductance. This equation I can call it as equation number 1. At the same time I can say that this EMF induced in the second coil due to first coil, this I can write down as A, which is equal to nothing but N2 into phi 1. Why? EMF is induced in the second coil due to change in magnetic flux in the first coil. Therefore here is the phi 1. And N2 is nothing but the number of turns of the second coil. While your phi 1, this phi 1 value can be written as, that is, change in magnetic flux can be written as K into N1. K is nothing but your coefficient of coupling. N1 is nothing but the number of turns. So just now I have told you that if K value is more, means your phi is more. So here this phi 1 is equal to K into N1. So if I put this phi 1 value in the place of phi 1, I can get it that it is N2 N1 into K. So this is nothing but I am getting as a induced EMF in the second coil. So this is nothing but my induced EMF in the second coil. Now we are knowing that in self-inductance we have derived the relation. That is, your self-inductance L is directly proportional to the number of turns. So here first coil has a number of turns N1. So I can say that self-inductance of the first coil is directly proportional to N1 square. Secondly, L2, self-inductance of the second coil is directly proportional to N2. Now here what I am getting value of N2 and N1. So to write N2 by what I say under root of L2. To write N1 I write under root of L1. Means now I am getting that induced EMF across secondary coil due to change in magnetic flux in the first coil, that I will write down as a K into root of L1 into root of L2, which is equal to K into bracket root of L1 root of L2. This is my equation number 2. And now if I concentrate on equation 1 and equation 2. So if I concentrate on that equation 1 and 2, then here I can write down now your M must be equal to K into bracket L1 L2, where M is the mutual inductance, K is the coefficient of coupling, L1 is the self-inductance of first coil L2 is the self-inductance of second coil. Fine. Means now your value of M is dependent on K, coefficient of coupling. Now there are different cases for this K value. What are different cases? I can concentrate the first case, that is if K value, case number 1, if I am saying K value is equal to 1, if this K value is equal to 1, your M is equal to nothing but under root of L1 and 2. And this is possible. This K value is 1. This is possible only in case of a device which is to be called as a transformer. So only in case of transformer K value is 1. And such type of coupling where K value is equal to 1 is to be called as a perfect coupling. So when two coils are perfectly coupled with each other to generate induced EMF, K value is equal to 1. And when there is a perfect coupling, then that case is to be called as an ideal case of coupling. So in the ideal case of coupling, K is equal to 1, and that type of coupling is called perfect coupling, and this perfect coupling is possible only in case of a transformer. Clear? And to get this ideal case, the thing is that whatever this coil 1 and coil 2, if you want that the coupling between these two coils should be perfect, at that time both the coil, I can say both coil should wound on the same core. The winding should be on the same core. So same core means what? I can consider this is one of the core. Here I can wound first coil, which I can call it as the first coil or primary coil. And over that primary coil, I can wound the secondary one. Just wait, I will show that another secondary winding here like this. Here is the secondary winding. So if I am going to wound both the coil on the same core, then I can say that that type of winding, that type of coupling is to be called as the ideal coupling. That coupling I am going to call it as a perfect coupling. And for perfect coupling, K is equal to 1. And that is possible only in case of a transformer, which we are going to see in the next topic. This is one important ideal case. The second important ideal case is nothing but if K value is greater than 0.5. This is possible only in case of home appliances. So whatever the electric instrument we are going to use, in case of that home appliances, whatever transformers are going to be used, for that transformer K is greater than 0.5. And that type of coupling is to be called as a tight coupling. And this is the second case. And third case is there where this K value is less than 0.5. Again, this type of coupling is used in the home appliances only, and that type of coupling is to be called as a loose coupling. Clear? So now, see here in this case, ideal transformer K is equal to 1. Means whatever our line transformer we are using. Home appliances transformer uses coupling which is either tight coupling or loose coupling. So either we want K is greater than 0.5 less than 1 and K must be less than 0.5. Means what? If I reduce value of K, I can use that in general purpose. If value of K will get reduced, automatically M value will also goes on reducing. Now to reduce that value of K, what are the different ways? I can say that to reduce this value of K, I can use two separate cores. Two separate core means what? Like this. I can use a first core where this winding is there. I can use this is the second core where coil winding is there. Right? And now, furthermore, this K value will be dependent on. Okay, I have used separate code so that your K value will become minimum. But this K value is also dependent on two more factors. Which two more factors? Separation between the coil. Separation distance means this distance. Clear? And second thing is nothing but this K value is also dependent on one more factor. This K value is going to be dependent on one more factor, that is nothing but the coil inclination angle. Coil inclination angle means what? See here. These both the coils are parallel to each other. If coils are parallel, if I am saying that coils are parallel, means theta value is equal to 0 degree. If theta value is equal to 0 degree, then your K value is maximum. And if your coil 1 is perpendicular to coil 2, means theta value is equal to 90 degree. At that time your K value is nothing but minimum. So just by doing this precaution, we can reduce the value of K, and if we reduce the value of K, then either we can use the tight coupling or we can use the loose coupling. So in this manner, this coupling concept you can use in case of your ideal case as well as for practical case. Ideal case means K is equal to 1, which is called perfect coupling. That is used in the ideal transformer. And second case is what? Your K value, either K value is greater than 0.5 but less than 1. That type of coupling is called tight coupling. And I can say K value is less than 0.5. So that is called as a loose coupling. Means in case number 2 and case number 3, we have reduced the value of K. And to reduce the value of K, what is the thing you can do? First thing, you can use separate code. Second thing, to reduce the K value, this K value is dependent on separation between the coil. K value is also dependent on angle inclination between the coil. So if I want K is minimum, coil should be perpendicular to each other. And if I want K is maximum, then the coil value should be parallel to each other, that is theta is equal to 0. Clear? So this is nothing but about the coefficient of coupling between the two circuits. Fine? Thank you.